Hello, everybody. This is Mr. Tam back with another episode of Science and Technology. So, last time we met, I introduced to you the concept of energy efficiency, and this time I would like to follow through with a few practice examples. So, we're going to do a couple. Some are a little more tough than others, but overall, very straightforward and deals with this particular equation that you see at the top, where it says energy efficiency in percentage is equal to the amount of useful energy divided by the amount of energy that's consumed. Of course, this is a little typo here. This should be multiplied by 100 because we want to express this as a percentage. So what I have here is a computer that is 87% that consumes 375 kilowatt hour of energy. How much useful energy does this provide? So what you see here, 375 kilowatt hours of energy, is exactly that, energy. But what we're used to seeing in terms of joules, we've now expressed as kilowatt hour. So both are valid forms. So let's plug this into our equation where we have 87% on the left, and that's equal to the amount of useful energy, which we are actually looking for. So I'm going to put this as X over the amount of energy consumed, which is 375 kilowatt hour. It's very important every time that you write down a number that we put a unit next to it, and that way we know for sure that that's what we're talking about. So to isolate for X, we first get rid of the 100 that's next to the equation, and we divide, of course, both sides by this 100, leading us to have 0.87 is equal to X over 375 kilowatt hour. And of course, if we wanted to isolate X at this point, we simply just cross multiply and we end up with X as a value of, and let's get this calculated here, of 0.87 times 375, which gives me 326.25. And of course, if you don't remember the specific unit, you can always look back and say, well, if you wanted to use energy efficiency, both units have to match in that regard. And because both of them have to match, you have to have the same unit. And therefore, the unit is kilowatt hour. All right, I'm going to give you a moment to, if you want to pause this video, take a picture of it or save it as a screenshot. And we will now move on to another question involving energy efficiency. So the next part to this is a television set. So I'm going to clear this. I'm going to go down a little bit here. And we see that television provides 83% of, 83% efficiency. That uses 4,600 joules of useful energy. So the same setup, 83% on the left, is equal to 4,600 joules, which you find on the right, divided by the amount of energy consumed. So we're going to leave this as energy consumed, or X, depending on what you want to label, okay, times 100%. So the same procedure as last question where we divide both by 100, and this leaves us, of course, with 0.83 on the left and 4,600 joules over X on the right, or the energy amount consumed. And when I go to cross multiply this, of course, it ends up being 0.83. X is equal to 4,600 joules. To solve for X, we divide both sides now by 0.83, which leads us to a final answer of 4,600 divided by 0.83, which is 5,542.2. And of course, because both units have to match, since we're using joules at the beginning, this will be joules in the end. And that's basically what I found to be 5,542.2 joules of energy that is consumed overall. So that being said, we can now move on to the next question. Let's clear all this up and move on to question 3, where it gets just a touch more difficult. An oven consumes 425 kilowatt hour of energy in order to provide 386 kilowatt hour of thermal energy to cook the food inside it. What is its energy efficiency? Well, this one is probably the easiest variety out of all of them because they're basically just looking for the percentage. And this procedure is very much similar to when you guys are taking tests, where say, for example, the total of the test is out of 30, and you wanted to know what the percentage was that you got. If you got 26 out of 30, let's say, very, very good mark. So you would simply take 26 and you would divide it by 30. The units would cancel each other out, multiply it by 100, and you end up with percentage. It's the same idea here, but you just have to figure out which one is useful. So when you're in an oven, for sure, the heat that it provides is the useful amount needed to cook the food. So I have 386 kilowatt hour on top, followed by 425 kilowatt hour on the bottom. And of course, I go to multiply this by 100, which leads me to 386 divided by 425 times 100. And if I had any oven that was this efficient, I would purchase it right away at 90.8% efficiency, which is pretty incredible. So those are the three easiest variety of energy efficiency problems. We can now move on to things that are a little more difficult. So if you'll notice with number 4, where it says an electrical appliance consumes 24 kilowatt hour of energy, and it provides 61,200,000 joules of energy. Because these units are different, we have to make sure one matches the other. So the easiest way I propose that you guys go about doing this is to take 24 kilowatt hour, and we're going to convert those two units into joules. And how we do that is essentially by turning kilowatts into watts and hours into seconds. So that being said, I want kilowatts in watts, which means I have to multiply this by 1,000. And I want to go from hours to seconds, which means that I have to first multiply by 60 to get to minutes, and then multiply by another 60 to get to seconds, at which point it's exactly the same thing as if I multiplied everything, or that hour, by 3,600. So this is what it looks like. I have 1,000 watts, which represents the kilowatt, and for the hour, I have 3,600 seconds that represents that hour. And of course, if I multiply everything out, 24 times 1,000 times 3,600, you end up with 86,400,000 joules of energy being consumed. Now, that being said, this simply comes down to another efficiency problem where energy efficiency is equal to the amount of useful, which is 61,200,000 joules, divided by 86,400,000 joules. Of course, those units cancel one another out when you go to multiply by 100%. And the answer to the following, 61,200,000 divided by 86,400,000 times 100% ends up giving you an efficiency of approximately 70.8% if we were to round this off to 1 decimal place, or the 10th position. So a little more difficult with this question, but nothing that you guys can't handle. So we now move on to the next question, where now Xantha is testing out various electrical devices to determine which is the most energy efficient. While conducting a test, she notes that one of these devices consumes 550,000 joules of energy and loses 315 joules at the same time. What is the energy of the efficiency of this device? So the important part to this question that's quite different from everything else is the talk of loss of energy. And what that means is you'll see it as wasted energy, or on a typical government exam, what you'll see is the word dissipated. So either one can mean the same thing, and it just means that 315,000, not useful. So the first step is always to take the amount consumed and subtract the amount wasted, which will give us the amount that's useful. So if I do consumed, which is 550,000 joules, minus 315,000 joules, 550 minus 315,000, give me 235,000 joules of energy. Now that being said, I'm going to now take energy efficiency and I'm going to solve for it. I have my useful, which is 235,000 joules, divided by now the 550,000, which was originally consumed, and I'm going to multiply it by 100. And again, just like finding your mark, this will be expressed in a percentage. So when I have 235 divided by 550 times 100%, this gives me a total of approximately 42.7% if I round it off to the nearest 10th position. Wonderful. We are now at the end of our little practice session here, where number 6 is the ultimate test to see if you remember anything that we've learned in the past when it comes to dynamic electricity. So this is a combination of energy efficiency along with dynamic electricity that we've learned in the past. And I will remind you guys the formulas that you do need to use to figure this out. So first and foremost, we'll read the question that I'm plugging in the toaster, draws 8 amps of current and 24 volts from the outlet. The toaster is in use for 2 whole minutes. 7,500 joules of this energy is, again, we talked about it earlier, dissipated. What is the energy efficiency of this toaster? So to find this, we basically need to figure out the amount of energy consumed, and we need the amount of useful energy, neither of which is given. So first, let's remind ourselves of the amount that the toaster gives off, or the toaster draws from the outlet. I want to draw a little toaster here for you guys. There's my little Eggo waffle here. Okay, and with my Eggo, if I plug it into the wall, it tells me that there's 8 amps of current and 24 volts of potential difference, which tells me that if I take power and I make this equal to voltage times current, that'll help me find the wattage. Oops, sorry about that, not 8, 24 volts, 24 volts multiplied by 8 amps. So 24 times 8 gives me 192 watts. This is a 192 watt toaster being used for 2 minutes. Now to find the amount of energy, we always take power and we multiply it by the amount of time we use it for. And time, when you're using this energy, is never in minutes. So we have to first change this to seconds. So this 2 minutes right here, we're going to multiply this by 60 to tell us that it's 120 seconds. So that being found, I now have my power, which is 192 watts, multiplied by 120 seconds, which lead us to a grand total of 23,040 joules of energy being consumed from the outlet. So this is the amount of energy consumed. They also tell you that there's a certain amount of energy dissipated. So I'm now going to take 23,040 joules and subtract 7,500 joules from this amount. So I'm going to subtract 7,500, and I now have 15,540 joules of energy. That is useful. That actually goes towards heating up my Eggo waffle. Okay, so I now am able to finish with the last step here, where I have 15,540 joules that I use to heat my toast or bagel or Eggo, and I divide this by the amount consumed, which is 23,040 joules times 100%. At which point it gives me a grand total of approximately 67.4%. And that is how you go about solving probably one of the more difficult questions that may come up on a test or a quiz. So I hope you found this video helpful. What's very important is that you guys keep safe, that your families are doing well, and that you keep up the great work. Because I know that if you're watching this, it means that you want to stay up to date. So with that being said, I will see you guys in the next episode where we will go through some more science. So, au revoir, arrivederci, bye-bye.